Hello friends, welcome to Made Easy Solutions. Friends, in previous video lecture, we have learned representation of signed binary numbers. Today we will learn arithmetic operations on these numbers and we'll check the role of carry and sign bit to represent the result. So let's move towards our today's lecture. Welcome friends in our today's lecture, that is signed binary numbers and its arithmetic. This is the 10th video lecture of the video lecture series Number System Arithmetic. Today we will learn arithmetic operations like addition and subtraction on signed binary numbers. So let's start. We will perform arithmetic operations using 2's complement representation. Let's consider 8-bit signed binary numbers. So using 2's complement representation, the 8-bit signed binary numbers we can write are minus 2 power n minus 1 to 2 power n minus 1 minus 1. Now if you see over here, I have taken n minus 1 only in the range of negative numbers, while in the range of positive numbers I have taken 2 power n minus 1 minus 1. This is because in previous video lecture we have learned that using 2's complement representation we can represent positive numbers from 0 to onwards and negative numbers from minus 1 to onwards. We do not get minus 0 in 2's complement representation. So here n is 8. So we will have minus 2 power 8 minus 1 to 2 power 8 minus 1 minus 1. So the numbers we can write are minus 2 power 7 to 2 power 7 minus 1. 2 power 7 is 128. So we can write minus 128 to plus 127 numbers in decimal, and that are 1 1 1 1 1 1 1 1 to 0 1 1 1 1 1 1 1 in binary. Now let us consider any two numbers which lies in this range minus 128 to plus 127. So let us consider 5 and 14. Now we will perform arithmetic operations on these two numbers. So first we will perform addition operation. Now we have four possible cases here. Case 1, both the numbers are positive. Second case, both the numbers are negative. Third case, 14 is negative but 5 is positive. And fourth case, 5 is negative and 14 is positive. So let us consider first case, that both the numbers are positive. So we can write the equation as 5 plus 14 is equal to 19. Now consider second case, that means 14 is negative. So we can write it as 5 plus minus 14 is equal to 5 minus 14 is equal to minus 9. This is because according to mathematical conventions, if a plus sign is present before parenthesis, then the number present in parenthesis do not change its sign convention. And if a minus sign is present before a parenthesis, then the number present in parenthesis changes its sign convention. So here 14 will not change its sign, therefore we get subtrahend larger than subtractor, and that is negative, so we will get negative result. 5 minus 14 equal to minus 9. Now let us consider 5 as a negative number and 14 as positive number. So we can add them as minus 5 plus 14 is equal to plus 9. Now as here our larger number, that is 14, has positive sign, our result will be positive. Now consider our final case, that both numbers are negative. So we can add them as minus 5 plus minus 14 is equal to minus 5 minus 14 is equal to minus 19. Now similar to case number 2, plus sign is present, so 14 will not change its sign, and that's why we get minus 5 minus 14 is equal to minus 19. Now let us consider subtraction operation on these two numbers. Again we have four cases, that 5 and 14 both are positive, 5 and 14 both are negative, 5 is negative and 14 is positive, as well as 14 is negative and 5 is positive. So let us consider first case, that 5 and 14 both are positive. So we can subtract them as 5 minus plus 14 is equal to 5 minus 14 is equal to minus 9. Now again, according to mathematical convention, if a minus sign is present before a parenthesis, then the number present in parenthesis changes its sign convention. So 14 will change to negative now. That's why we get here minus 14. Now consider second case, that 14 is negative and 5 is positive. So we can subtract them as 5 minus minus 14 is equal to 5 plus 14 is equal to 19 decimal. Now according to the same mathematical convention, negative sign is present, so 14 will change its sign convention. That's why we get plus 14 here. That means in next two cases also, the number which is subtrahend will change its sign. Now consider third case, that 14 is positive and 5 is negative. So we can subtract them as minus 5 minus plus 14 is equal to minus 5 minus 14 is equal to minus 19 decimal. And our final case, that 5 and 14 both are negative. So we can subtract them as minus 5 minus minus 14 is equal to minus 5 plus 14 is equal to plus 9. Now if you compare all these 8 equations, we will find that equation 1 of addition operation is similar to equation 2 of subtraction operation. You can see over here 5 plus 14 is equal to 19. 5 plus 14 is equal to 19. Similarly, equation 2 of addition operation is similar to equation 1 of subtraction operation. 5 minus 14 is equal to minus 9. You will get same here, 5 minus 14 is equal to minus 9. Equation 3 of addition operation is similar to equation 4 of subtraction operation. Minus 5 plus 14 is equal to minus 5 plus 14 is equal to 9. And equation 4 of addition operation is similar to equation 3 of subtraction operation. You can see over here, minus 5 minus 14 is equal to minus 19. Here you are getting same, minus 5 minus 14 is equal to minus 19. So conclusively we have only 4 equations to consider. Now as this is a simple addition operation, we will neglect this case in this lecture. We will consider these 3 cases because these 3 cases includes negative numbers. So let's consider equation 2, that is 5 minus 14 is equal to minus 9. Now as we have learned in the video lectures of binary subtraction using 1's complement and 2's complement, also decimal subtraction using 9's complement and 10's complement, that we take the complement of the subtrahend, maybe 9's, 10's or 1's and 2's, and then add the complement into the subtractor. So here minus 14 is the complement of plus 14. So first we will find the complement of plus 14, that is minus 14, using 2's complement, and will add into 5. So we can rewrite the equation as 5 plus minus 14 is equal to minus 9. First we will write 5 and 14 in binary. Now as we have considered the 8-bit binary numbers, we will write 5 and 14 in binary using 8 bits. So in these 8 bits, MSB will be a sign bit and the remaining 7 bit will represent the magnitude of these numbers. So 5D will be 0 0 0 0 0 1 0 1 in binary, and 14 decimal is equal to 0 0 0 0 1 1 1 0 in binary. This MSB indicate that 5 is positive. This MSB indicates that 14 is positive. Now we will represent minus 14 using all the methods because 14 is our subtrahend which is negative. So first we will represent minus 14 using sign magnitude notation. So here this MSB bit will change to 1 to indicate minus 14 and magnitude bit will remain as it is. So our number will be 1 0 0 0 1 1 1 0. So sign magnitude notation of minus 14 is 1 0 0 0 1 1 1 0. Now we will represent minus 14 using 1's complement notation, because in order to represent minus 14 using 2's complement notation, we must write it using 1's complement notation first. So in 1's complement notation, all the magnitude bits is inverted. So our number will be 1 1 1 1 0 0 0 1. So 1's complement notation of minus 14 is 1 1 1 1 0 0 0 1. Now we add 1 to the LSB of 1's complement to get 2's complement of a number. When we add 1 to this LSB, we will get the result 0 and carry will be 1, and carry will be shifted to this bit. So this bit will change to 1 and this bit will change to 0. So our number will be 1 1 1 1 0 0 1 0. So 2's complement notation of minus 14 is 1 1 1 1 0 0 1 0. Now add this minus 14 to plus 5. First we will write 5 in binary, that is 0 0 0 0 0 1 0 1, and then we will add minus 14 represented in 2's complement notation, and it is 1 1 1 1 0 0 1 0. Now let's add it. Start the operation from LSB. So 1 plus 0 1, 0 plus 1 1, 1 plus 0 1, 0 plus 0 0, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1, and 0 plus 1 1. So our carry in this case will be 0. Now here the MSB bit, that is sign bit, is 1. That means the result is negative and in 2's complement form. So to get the result in original form, take 2's complement of this number again. So first find 1's complement. So all these magnitude bits will be inverted. So our number in 1's complement form will be 1 0 0 0 1 0 0 0. So let's write it 1 0 0 0 1 0 0 0. Now find 2's complement. So add 1 into this LSB. So 0 plus 1 will get 1. So this bit will change to 1. So our number will be 1 0 0 0 1 0 0 1, and it is the sign magnitude notation of minus 9, because this bit indicates negative sign and these remaining 7 magnitude bits represent 9 in binary. Here you need to watch the video based on binary to decimal conversion. Here I tell you a easy way to convert binary number into decimal. We will consider weight of such bits which is 1 only. So weight of this bit is 1 and weight of this bit is 8. So 8 plus 1 is 9, and this bit indicates a sign. You can calculate the magnitude from the 2's complement form also, as we have seen in the previous video. So just add the weights of bits which is 1. Consider weights of all magnitude bits positive and that of sign bit negative. So we can find it this way. Weight of this bit is minus 128. Weight of this bit is plus 64. Weight of this bit is plus 32. Weight of this bit is plus 16. Weight of this bit is 8, but as this bit is 0, 8 multiplied by 0 will be 0. Weight of this bit is 4. Weight of this bit is 2, and weight of this bit is 1. Now if you add these weights, we will get minus 9. Here we are getting correct result. So let's consider our next case, that is minus 5 plus 14 is equal to plus 9. We can rewrite this equation as 14 plus minus 5 is equal to plus 9. That means here we have to find minus 5. That means 2's complement of plus 5. So first we will write 5 and 14 in binary form. 14 is 0 0 0 0 1 1 1 0 and 5 is 0 0 0 0 0 1 0 1. Now let's find out 2's complement of plus 5, that is minus 5. So first write down minus 5 using sign magnitude notation. So here this bit will change to 1, remaining bits will remain as it is. So sign magnitude notation of minus 5 is 1 0 0 0 0 1 0 1. Now represent minus 5 using 1's complement notation. So here invert each magnitude bit. So our result will be 1 1 1 1 1 0 1 0. So let's write it down. 1's complement notation of minus 5 is 1 1 1 1 1 0 1 0. Now add 1 into this LSB to get its 2's complement. 0 plus 1 will get 1. So this LSB will change to 1. Remaining bit will remain as it is. So 2's complement of minus 5 will be 1 1 1 1 1 0 1 1. So let's write it down. 2's complement notation of minus 5 is 1 1 1 1 1 0 1 1. Now add this minus 5 represented using 2's complement notation with 14. So first write down 14 in binary. 0 0 0 0 1 1 1 0 plus 1 1 1 1 1 0 1 1. We will get 0 plus 1 1, 1 plus 1 0 carry 1, 1 plus 0 plus 1 0 carry 1, 1 plus 1 plus 1 1 carry 1, 0 plus 1 plus 1 0 carry 1, 0 plus 1 plus 1 0 carry 1, 0 plus 1 plus 1 0 carry 1, and 0 plus 1 plus 1 0 carry 1. Now here our MSB is 0, that means our result is positive. So find out magnitude using these magnitude bits. It is 1 and it is 8. So 8 plus 1 is 9. So it is a sign magnitude notation of plus 9. In previous example our carry was 0 and in this example our carry is 1, but our sign bit is indicating the sign of our result. Hence carry has no role in the sign binary arithmetic using 2's complement. Let's verify with our next example. Our next example is minus 5 minus 14 is equal to minus 19. That means here we have our both numbers negative. So we can rewrite this equation as minus 5 plus minus 14 is equal to minus 19. So find 2's complement of 5 and 14 both and then add them. So first write 5 and 14 in binary. So 5 is 0 0 0 0 0 1 0 1 and 14 is 0 0 0 0 1 1 1 0. Now let's find out minus 5 and minus 14. So first we will represent them using sign magnitude notation. So only this bit will change to 1. Only this bit will change to 1. So sign magnitude notation of 14 is 1 0 0 0 1 1 1 0. and that of 5 is 1 0 0 0 0 1 0 1. Now let's find out ones complement of both the number. So this magnitude bits will be inverted. So here we will get 1 1 1 1 0 0 0 1, and here I will get 1 1 1 1 1 0 1 0. So let's write it down. Ones complement notation of minus 14 is 1 1 1 1 0 0 0 1, and that of 5 is 1 1 1 1 1 0 1 0. Now add 1 into this LSB. So we will get 1 plus 1 0, and carry will be shifted to this bit. So this bit will change to 1 and this bit will change to 0. Similarly here, when we add 1 into this LSB, this bit will change to 1 because 0 plus 1 is 1. So let's write it down. 2's complement notation of minus 14 is 1 1 1 1 0 0 1 0, and that of minus 5 is 1 1 1 1 1 0 1 1. Now add these two numbers. So first write down minus 5 1 1 1 1 1 0 1 1, and then add minus 14 1 1 1 1 0 0 1 0. We will get 1 plus 0 1, 1 plus 1 0 carry 1, 0 plus 0 plus 1 1, 1 plus 0 1, 1 plus 1 0 carry 1, 1 plus 1 plus 1 1 carry 1, 1 plus 1 plus 1 1 carry 1, and 1 plus 1 plus 1 1 carry 1. Now here we have 1 carry and sign bit 1. So this result is negative and in 2's complement form. So again obtain 2's complement of the magnitude bits to find out its magnitude. So first find 1's complement. So 1's complement of this number is 1 0 0 1 0 0 1 0. So let's write it down. 1 0 0 1 0 0 1 0. Now find its 2's complement. So add 1 into this LSB. So we'll get 0 plus 1 1. So this LSB will change to 1. So we will get 1 0 0 1 0 0 1 1, and it is sign magnitude notation of minus 19. You can add the weights of the bits, which is 1. Weight of this bit is 16, weight of this bit is 2, and weight of this bit is 1. So 16 plus 2 plus 1 is 19, and this bit indicates negative sign. So it is minus 19. You can find it from here also. Just add the weights of bits, which is 1. The weight of magnitude bits are positive and the weight of sign bit is negative. So we can write it as weight of this bit is minus 128, then plus 64, then plus 32, then 0, then plus 8, then plus 4, then 0. You will get minus 19. Now if you see here, our carry is 1 but result is negative, and in this example our result is negative but carry is 0. What does it mean? It means that carry has no role in the signed binary arithmetic. So we just discard it. The sign of the result is always indicated by the sign bit, not by carry. So here is our conclusion. In case of signed binary arithmetic, the sign of the result is always indicated by the sign bit, not by carry. Hence we discard carry here. But in case of unsigned binary numbers arithmetic, the sign of the result is indicated by the carry generated. I hope your concept is very much clear now about carry and about sign bit. Now you may ask me, sir, how to define signed and unsigned numbers? It is very much clear. When you program a gadget, you have to define the signed and unsigned numbers. If you do not define the binary numbers are by default unsigned. So I hope your concept is very much clear about binary numbers now and its arithmetic. Press like button if you like this video, share it among your friends as much as you can. Also subscribe my channel Made Easy Solution and press the bell icon to get notification of future videos. Thank you.